The classification of hadrons was proposed by Murray Gell-Mann and Yuval Neeman. This was formulated to encompass many short-lived resonance particles and also the relative stable hadrons. It is called eightfold way. In the eightfold way, these multiplets are accommodated. Multiplets means they are particles or members having similar mass but different charge. So the elementary particles, the multiplets are two super multiplets are there. One is the spin half baryon multiplet, in which the charge and strangeness are different. Then you have spin zero mesons which also have the charge and strangeness different. So in the absence of any interaction, each super multiplet would be the same. It is only due to this interaction that it is splitting up into the multiplet state. Under the strong interaction, the baryonic state is splitting into Z, sigma, lambda and nucleons. Then on further action of the electromagnetic interaction, it will split up into the multiplets. This is the baryon super multiplet. Without these interactions, these would have been the same. Under the influence of the strong interaction, this has been split up as Z, sigma, lambda and nucleon. They are having similar mass but different charge. Then further on the action of electromagnetic interaction, it is splitting up into Z minus, Z0, sigma minus, sigma 0, sigma plus, lambda 0. Then nucleon is splitting up into neutron and proton. So under the strong interaction, it is only the same particle, but when electromagnetic interaction comes, it is splitting up into neutron and proton. So this can be represented in a super multiplet form. This is another way of representing super multiplet of spin half baryons. Here I have shown the charge varying from -1, 0, +1 and strangeness 0, -1, -2. So in this order, so strangeness 0, charge 0, you have the neutron. Then you have the proton, which is having strangeness 0, charge +1. Then you come to strangeness minus, you have omega minus with a strangeness minus and charge -1. Then you have the particle lambda 0 bar and sigma 0. Both are having strangeness -1 and charge 0. Here you are having sigma plus, which is having strangeness -1 and charge +1. Similarly, strangeness -2, charge -1, you have Z minus and Z0 with strangeness -2 and charge 0. So this is the super multiplet of spin half particles. Next, let us look at the spin zero mesons. Mesons also can be represented in a similar manner using the super multiplet structure. So here you have the strangeness varying from +1, 0 and -1, charge varying from -1, 0 to +1, and you have the particles K0 cation, K0, K plus, pi minus, pi 0, pi plus, eta 0, K minus and K0 bar. This is the antiparticle. So this also shows the super multiplet. They are also splitting up due to the interaction. Next, let us look at the baryon super multiplet of spin half particles except omega minus. Omega minus is having spin 3/2. So this consists of short-lived particles or resonance particles. So these are delta, delta minus, delta 0, delta plus, delta double plus, delta double